Today we are going to be solving problem 7. 7a asks for an aromatic neutral molecule. So let's find out what an aromatic means first. So an aromatic molecule is cyclic, planar, and its pi electrons follow the 4n+1 rule. Whereas an aromatic is also cyclic and planar, but its pi electrons follow the 4n rule. And a non-aromatic is either not cyclic at all, or if it is cyclic, it's not going to be planar, and it does not follow, its pi electrons do not follow the 4n rule or the 4n+2 rule. Okay, so since 4a is asking for a neutral molecule, we can instantly cross off 7. That leaves us with molecule 1 and 2. So let's take a closer look at 1 and 2. Molecule 1 has 1, 2, 3, 4 pi electrons. However, it also contains an sp3 carbon. This sp3 carbon interrupts the communication between the p orbitals, so they can't all overlap and communicate with one another. Therefore, molecule 1 is considered to be a non-aromatic. Now let's look at molecule 2. Molecule 2 has 1, 2, 3, 4 pi electrons. However, there are also lone pairs on the oxygens, making this 1, 2 groups there. So in total, there are 6 pi electrons on this molecule, making this an aromatic. It is cyclic, and there's allowance for conjugation of the p orbitals all around. Therefore, our answer for 7a is molecule 2. 7b is asking for an aromatic charged molecule, which means we can instantly cross out 1 and 2. Now let's take a closer look at molecules 3 to 4. So molecule 3 has 1, 2, 3. Since this has 3 electrons, this doesn't go with the 4n+2 rule in the aromatics, neither the anti-aromatic rule, which is the 4n rule. Therefore, this can be crossed out as this is non-aromatic. Next, let's look at molecule 4. So it has 1, 2, 3, 4, 5, 6. 6 pi electrons. However, there is the presence of an sp3 carbon right here. This sp3 carbon interrupts the conjugation as the p orbitals can't communicate with one another because it's like wedged right in between. Therefore, this is the non-aromatic as well. Molecule 5. It has 1, 2, 3, 4 pi electrons, and no presence of an sp3 carbon to interrupt the conjugation. Therefore, it is an anti-aromatic. It is an anti-aromatic as it contains 4 pi electrons and satisfies the 4n rule, where n would be equal to 1. We can cross 5 out. Next, we have molecule 6. Molecule 6 actually looks like this. This is clear evidence that there's presence of an sp3 atom, being nitrogen, and sp3 atoms tend to interrupt conjugation of the p orbitals, making this a non-aromatic. Lastly, we have molecule 7. Molecule 7 has 1, 2, 3, 4, 5, 6 pi electrons. Since it has 6 pi electrons, it satisfies the 4n+2 rule with aromatics, where n is equal to 1. Therefore, our answer for 7b is molecule 7. 7C asks for a anti-aromatic charged molecule. Since we already solved this, we can see it is clearly going to be molecule 5. Just to do a little review, we said there were 1, 2, 3, 4 pi electrons, and there was no presence of an sp3 atom. Therefore, this is an anti-aromatic charged molecule. And the answer for 7C is 5. 7D. 7D asks us to describe molecule 6 as either an aromatic, anti-aromatic, or non-aromatic. Molecule 6, we find this here, is non-aromatic as we've described previously. It contains an sp3 atom, the nitrogen, which interrupts the flow of conjugation of the p-orbitals. Therefore, the answer for 7D is a non-aromatic. 7E. How many non-aromatic molecules are in the image? So since we already solved this, we can just count the number of non-aromatics. So if I erase this, this is a non-aromatic too, as there's an sp3 carbon interrupting the flow of conjugation with the p orbitals. And this was aromatic, so that's not part of our option. Okay, and if we count the total number of non-aromatics, we have 1, 2, 3, 4. 4 non-aromatics. And that completes problem 7.